Okay, hello everybody. Please take your seats. We will start now. Welcome in another our meetup. Today we are created the meetup with community of Krakow, Meet.js. Today we have three speakers plus one more special guest, who is Tomasz Borowicz. He is a software engineer at Vivet. He will tell us about some new tech interesting news, and we'll next have three more guests, more speakers. The first speaker is Amir Omari. He is Node.js developer in our company, Andersen. He will talk about runtime validation based on your TypeScript expectation. So, let's welcome Amir. No, sorry. Yeah, sorry. First, Tomasz. He is our first special guest. Sorry very much. Sorry.
Yeah, so hi everyone. I'm here to talk about everything that happened in JavaScript during the summer. And I'm a full-stack software developer at Virtus Lab. I have a podcast. I'm a co-host of a podcast. I'm writing a front-end newsletter. So if you want to try, you have a few seconds to scan it. And OK, let's go. So we'll begin with Node. A lot have happened in the area of Node.js alternatives during the summer. And we'll begin with the Dino. And Dino raised $21 million for developing their Dino company. And they're going to focus on building their cloud, Dino Cloud. And what's interesting, they already have quite big clients. The Supabase, it's the open source Firebase alternative, and quite a big name in front-end area, Netlify. They both use Dino edge functions under the hood to use their edge functions. And that's not the end in the Dino. They got their first dedicated framework. It's called Fresh. It's for server-side rendering. It uses Preact. It uses islands architecture. We'll come back to this later. It's very lightweight, and it's nice to see that Deno is developing. Oh, and it's also compatible with Deno edge functions, as you can expect. And the most controversial news about Deno, in the next release, Deno will get NPM support. And if you remember Deno history, Deno have been created as the alternative to Node.js that is going to fix Node.js problems. And one of them have been Node modules folder and the NPM itself. So it's quite controversial to bring support for NPM. But you have to remember that it's only the import syntax sugar. There's not going to be any Node modules folder. Deno will handle NPM dependencies with its global cache, so there's no Node modules folder. And OK, another thing in the Node.js alternatives area is Ban. It's a new project that is a fast alternative for Node.js. They claim that they are 2 to 3 times faster both than Deno and Node.js. And user benchmarks see that it's not always true, but they're definitely not slower than Node and Deno. And why they're fast? They're written in Zig. If you ask me what Zig is, I can't explain it. It claims to be the better C++, but I don't know why it's better. It's faster. And Ban is the first big project to use Zig, so it tells something about this language. And another interesting fact, it uses JavaScript core under the hood. So it's a JavaScript engine developed by Apple, used in Safari. It's not using V8 like Node and Deno. V8 is developed by Google for Chrome. So it's nice to see Apple engine on the backend side finally. And a lot of marketing, a lot of hustle claims about those performance, but it's a lot more than the performance. They got faster NPM alternative. They've got TypeScript support. They use this as build under the hood, so it's very fast. And the one most interesting for me is macro support. So the macro is like a script that you use to generate code during the compile time that can generate more code. And it has the access to the tree of your code, how it's structured, and to types and all the meta types. So I haven't seen anything built with it yet, but other languages have it, like Scala. And there are quite crazy people doing crazy things with that. So I'm expecting some crazy things to happen in this area. And this is the news actually from yesterday, bank has raised $7 million for their company. And to be honest, they're quite cloning the Dino strategy. They have established the company. They're trying to build the cloud where you can deploy ban, and it's going to be very fast. We will see how it gets. It's got crowded in this area. We've got Node, we've got ban, we've got Dino. Competition is always good. OK, going next, we got Vue 2.7. And you might be surprised to see Vue 2 not free. But it actually brings Vue 3 features to Vue 2, mostly the compositions API. And it's fully compatible with Vue 3, so it's going to be a great tool for the migration. And talking about migrations, Vue 2.7 is the last Vue release. And Vue 2 support is going to end at the end of 2023. And for now, only about 25 projects have migrated. So we will see if they will manage to do that. And this situation is mostly caused by the libraries that are still updating. For example, Nuxt, the biggest library for server-side rendering, is still not compatible with Vue 3. So there are quite a lot of blockers. Yeah, I don't believe they will manage. OK, Astro. Astro is a server-side rendering framework, one more. And I said that we're going to come back to the island architecture because it's quite a new concept. At least I have seen it for the first time now. And it's implemented both by Fresh, this Dino framework, and by the Astro. And what it does is it assumes that there's a sea of static content of your website, and those are only small islands of interactivity. And with this assumption, you can render most of your page on the server side and only hydrate those small islands on the client side. So it's going to be very fast, and client's going to see your page faster than with the standard server-side rendering architecture. And why I'm excited about Astro is it's the first framework-independent tool I have ever seen. On this right side, you can see that you can mix a few frameworks in one file, and it's going to work. With one asterisk, if you're going into interactive world, you have to stick with one framework. But wherever you have those static islands, or you want to have a few interactive islands with few different frameworks, you can do that, and it looks pretty well. And also, quite big companies already use it, like IKEA and Google. Well, Cypress. Cypress have been the tool for building end-to-end tests. From now on, it's going to also be a tool for building the unit test. For components, you can render one component and test it. It's better than just because you have some visual preview. And my only concern here is that it's going to be too slow for unit tests, because if you're going to have hundreds or thousands of such tests, it might be kind of slow to start the browser and click in the browser, all those stuff. But we will see. I haven't seen any benchmarks on that. OK, Reassure. And another thing in the testing area, it's a tool developed by a Polish company called Callstack. And it's a tool for creating performance tests for components. So until now, if you wanted to have some performance tests, you probably go to Chrome DevTools, and you either use Chrome DevTools or use some framework-specific tool. And you click something, you benchmark something, you have some results. It's not repeatable. You cannot automate it. You cannot connect it to CI/CD. And what Reassure does is it gets you to create some scenario, and you can connect it to CI/CD. You can use it to optimize performance. It looks quite good. NPM. NPM got a new command, and if you ever had to debug Node modules, you know how miserable it is to understand what is going on there. And this command is npm query, and it's going to make it a little bit less miserable. You can use something like CSS selectors to query your Node modules to see what's going on. You can see some peer dependencies, so keep in mind there's something like that next time you're debugging your Node modules. And last but not least, we finally got better transform encapsulation in all major browsers. Yeah, you can see there. It landed in Chrome 1.4. And to explain it a bit, if you're animating something with transform, you can animate the translate, rotate, and scale. But if you wanted to animate them all, you needed to calculate all the intermediate state for all three of them. So it was quite redundant calculations. and now browsers can handle them for you. I don't know if I'm explaining it clearly, so you can see the difference here. On your left side, you have the previous API, and on the right there's the new one, where you have separate animations for each of those three, and they're gonna behave the same. And that's all for today. Thank you very much. At the end, I would like to recommend you. I would like to recommend you the app I'm building. If you like the news, if you want to get more personal news, you can scan it and download it. And thank you very much.
Thank you, Tomasz, for your presentation and some news from tech world. So let's welcome our first speaker, Amir. Amir, where you are? Come on. Yeah, 1 minute to plug in the laptop, and also there is a lot of people here. We are very, very grateful for that. So we are turn on the AC to, have some cool here. All right, let's make some cool. And please welcome Amir.
Thank you. I'm so glad to be here today. As you know, my name is Amir Omari, and today I'm going to discuss with you how could we improve our validation layers on the server side by generating the validation schemas directly from the types we've got in the TypeScript. But first, let's describe the problem. The problem is the validation is required when we build the server-side applications for all the left adapters, aka controllers, handlers, lambdas, whatever you call them, just to make sure that we have the information in the shape with the types that we expect. Secondly, unfortunately, the TypeScript does not really allow us to pass information of the types into the runtime, which makes it really hard to correlate sometimes, even impossible, the types we've declared within the TypeScript with the validation schemas we have. The third point is that any validation solution requires a separate schema to be defined. Unfortunately, such a schema may be different from the TypeScript types, and we'll understand why it is not very handy. Let's start by discussing the existing runtime solutions we've got so far. In general, those could be divided into two groups. The first group is the schema-based validations, where we have to declare our schema for validation, which is unfortunately totally decoupled from the types we declare. Either these are the classes, interfaces, or the types, whatever that holds the information of the types. As you can see, even a small typo, even a small mistake in the schema declaration will break entirely either the validation layer or the underlying executions. The second type of solution we may call a decorator-based. But even though such a schema declaration is now closer to our actual types, it is still impossible, unfortunately, to correlate the types. Because with the current state of the TypeScript decorators, there is no way to do the type checking, just because the decorator does not imply the fetching of the types of our properties, constructors, methods, etc. Let's now try to understand our problem and start with the type emission and how does it work in the TypeScript. In general, on the diagram, we can see the TypeScript code transformation. The first block is the TypeScript source code, which has got all the types we need which are being used by the compiler, of course, and some other tools for static analysis, etc. The second block is the JavaScript source code, which of course does not have any types information. It simply has got no models, no systems to be working with. Just so, because of that, once we run our JavaScript source code, in the runtime we lose entirely all the information we had before, which seems crazy, right? To be more precise, here is what happens with the types. Either you use the type or interfaces. These are never being committed, are never being output to the bundle, to the JavaScript source files. Only the enums are, and the classes, but they do not carry the types information anymore. Enums are being emitted just as simple objects. The classes are being the classes, but of course without the types. Now let's get back to our diagram. As we can clearly see, there is exactly one step, one operation that makes us lose all the type information. And it's actually the build of the TypeScript files. It's the compilation. To understand better what happens here, let's draw a diagram with the build time and the runtime split. We'll need it just a bit later. So within the build time, we have the build phase, which most commonly is nothing else but a simple TypeScript compiler execution, which emits us a set of JavaScript files as an artifact. These are being carried over to the runtime and executed. To be able to understand what happens with the build system, we'll have to speak of its internals. Of course, as we all know, TypeScript has got the abstract syntax tree, which holds all information about all the tokens within your source code, including the type information, of course. To be more precise, let's use the TypeScript AST viewer. On the snippet, within the snippet on the left, you can see that we've declared a simple type that has got exactly two properties. These are types primitives. And on the right side, we can see exactly the abstract syntax tree that TypeScript speaks about. We can see that we have the type alias declaration, property signatures. Those have got both the identifier, which is nothing else but, in our case, the name of our properties within the type, and the keywords of the respective types. Let's now try to build a general plan of what we'll try to achieve. Having the type information, since we now know how it at least looks like, we may think of generating the schemas, validation schemas, directly from them. Then we will have to expose the generated schemas to the runtime, just so we can do an actual payload validation. To do the schema generation from the types, we can use the library called TS.json schema generator. And just to understand how it works, let's briefly discuss its internals. First of all, the library brings a notion of a type, which is simply easier to reason about than the regular TypeScript AST nodes. As you can see, it's nothing else but simply an abstract class. And here we can see an example of a string type being very, very basic. The second notion is actually a parser. As you can see, it does nothing else but simply tries to create the types we just brought in directly from the TypeScript AST nodes. And the very last notion that we'll talk about is the type formatter. It does nothing else but simply converts the types we found, the types we've built ourselves, into the actual JSON schema definitions. If we fit this library with our source code, with our types, we'll see that it actually brings the JSON schema exactly in the way we declared within the types. We can see all the properties, all the corresponding types here. These are being required just because these are not declared as optional. And of course, we forbid to add additional properties to make sure our payloads are sanitized. a bit more advanced use case. Let's talk about it. Here at the right, you can see that we've declared an optional type of type Boolean, which actually have been emitted within the required array, which describes all the required properties we should be having. Apart from that, we can also declare some of the JSON schema rules, checking rules, such as the format, minimum length, minimum amount, much more of those. Since we now know that we can generate, and we have actually generated the validation schemas directly from our types, we can think of the solutions we can come with. The first one of them is to generate schemas after the main build process, which implies that we run our main build process, in our case a simple TSC invocation, then we generate schemas based on our types in a separate process. It is crucial to note. Once it's done, we should persist our schemas and somehow expose them to the runtime, just so we can do an actual validation in the runtime. The second solution is to do exactly the same thing, but within the main build process, which means that we can hook into the build process, get the types information, generate the schemas out of our types, and append the generated schemas directly to the abstract syntax tree. But today we'll cover only the first solution. Let's take some architectural assumptions just to ease our POC for today. Let's assume that we have a file structure that implies an easy access from the file system, and that we have a handler which is nothing else but simply a source code file, of course, which exports request response types. By the way, these could be interfaces, classes, whatever brings the types for you. And of course, the handler itself. Now that we have all the information we need, we've taken all the assumptions, we can discuss the solution and talk about the concrete steps. Since we'd like to make a more advanced solution, we'll have to split it into two parts. The build time and the runtime. Well, within the build time, we'll only have to generate the schemas and the types information. Once, based from the types information, once it's done, we have to persist them as the build artifacts. It's a crucial point. It is never being treated as a part of your source code, not anymore. Within the runtime, though, we'll have to load the schemas and decorate our handlers with the validation layer. And here's our diagram, but with a few small updates. First of all, as you can see, we have redefined our build phase. Apart from the TypeScript compilation, we now also do the generation of validation schemas, which means that our artifacts are now not only the set of the JavaScript files, but also the schemas, the validation schemas we'll have to use in the runtime. Since that's a build artifact, we can reason about it is also being loaded in the runtime, but I think we've introduced and called a handless loader, schema loader, however you call it. Handless loader itself is a pretty easy block. It should simply load your handlers directly from the file system, load the schemas that we've put next to each handler, then to decorate the handler with the validation layer. And here is the result. As you can see, what we've done, we have simply described our type, and we got exactly the schema we asked about. As a result, once we call our handler, we can see that with the vetted payload, the validation layer is being passed successfully, and we have got the response back from the underlying execution. But if we fail, for example, as you can see at this concrete example, the name is now not of type string, but the type Boolean. And we got exactly the error confirming that we've provided the wrong type. As a conclusion, Now we don't have to maintain our validation schemas, not anymore. These are now not the part of our source code. These are not being tracked by our Git repositories. We don't have to make sure we update them as well once we updated some code. The validation schemas are now directly generated from the types information, which leaves no room for any kind of inconsistencies between two at all. And of course, we can cover more advanced usages, such as the self-referencing types, complex union, determination keys, etc. There are some links you can use. Thank you very much.
Thank you very much, Amir. Thank you very much. Do we have any questions to Amir? Here.
So just a question. You have a very simple thing. So you have all the source of data written in TypeScript. Imagine the situation you have a backend on Python, front end on TypeScript and Kotlin. And at some point, data changed on the backend. How to process the schema changes?
First of all, I'm sorry, but we're talking only about the TypeScript here. Here's what it's all about. But you've mentioned the data changes. What kind of data do you mean?
Yes, I mean, right now, imagine, so if that was a front end, so on backend, they change the data. I mean, the schema of the data. So should you just rewrite your types and rebuild it each time?
Well, by the way, that's a good question. Since we can not only generate the information about the request, we can also declare and generate the response type, which leaves us room for some kind of self-descriptive backends, like, for example, the GraphQL does. You can simply call it and get all the information about all the types, all validations, etc. Does that answer your question?
I expected some magic, actually.
No magic.
Okay, thank you very much. Do you have any more questions? There.
So we use TypeScript as TypeScript types as a primary source of schema. But maybe I missed this point. But why not to use validation schema and generate TypeScript types based on that schema?
Here's the problem with that. Since the source code is the thing we track with our Git repository, is the thing we work with, why should we be adding additional step to our the development flow and affecting our developer experience to generating the types before we can use them? Instead, we do all have the types, right? We've got all of them. And now we can simply build the validation schemas. These are only being used by the runtime. I don't know what's about other developers, but I prefer to spend more time writing the code than running it.
Okay. Because I thought that we can generate, like, we take this schema and write something and apply some helpers, as I know from AGV, and you can just...
No, any kind of helpers meant. Actually, here's what happens. Again, we generated our schemas, right? We treated them and we persisted them as the build artifact. Yeah. Now that we run our code, what we need is to inject into the runtime a simple library that will load our handlers, load these corresponding schemas that we've put next to each of them, and then simply in the runtime wrap the functions up and do the actual validation before underlying executions.
Okay, thank you.
Thank you.
Thank you for this question. Do you have any more questions? Here.
Yeah, I have a question. Because TypeScript is kind of crazy. You have utility types, union types, map types. How does it cover all of that? Is it working, or there are some corner cases where you have some troubles with it?
It does work, thankfully, to this concrete library. Actually, we could be talking about building our own solution for that, but I do not see a particular reason since we've got a working library that is pretty easy to extend. That's why we had a look into internals, just because we now know that it has got some kind of types we can reason about. These are a lot easier to reason about than the simple TypeScript nodes, TypeScript AST nodes. We have got the parsers, those emit them. And what we can do, we can write our own parsers, or we could write our own type formatters. You've asked about utility types, some more advanced usages. It also covers them all, just because it happened that the library has got much more node parsers than the actual types, which these are actually being used, the node parsers, to cover more advanced cases. For example, the indexed access type, which, for example, if you imagine the union type and you would like to pick a single one of them or a simple interface and you would like to pick a type of some specific property, it is also covered by that.
Yeah, okay. Thank you.
Thank you too.
Thank you. I saw that we have another question here.
Thanks for the talk. I wanted to ask you a question about more practical side of things and developer experience. So when I'm developing, usually testing, trying out different stuff, the schema might change. So this solution looks very nice with this nice static build step at the end. But if you are in the process of development, you know, with like refreshing and reloading stuff, do you think this could be run like multiple times? Would I, for example, do you imagine I manually, every time I change something, I call the command to like rebuild my JSON schemas while I'm in the process of developing?
Good question. I haven't actually included it here, but what could be done? You could simply write a pause build script, and every time you do build with the watch, you are now not only calling the TypeScript watch, but you can use some kind of wrapper like a node daemon or the TSC watch library that does exactly that. It compiles the code and gives you the way to describe a shell comment that will be used, will be run right after your build that you've been watching on.
Okay, thank you. Do you have any more question? There.
Did you try it and is it performant? So did you try it and is it performant?
It actually works right now on the project I'm working on. We have designed it actually just because we had a crazy validation JSON schema, even sometimes outdated. As you may know, it just can happen. And so this brought us a lot more stability and reliability in the terms we're reasoning about.
And it's not and it's not really slowing you down while developing.
Could you please repeat?
It's not slowing you down while developing.
No,
you
not
don't
really.
need to wait much more.
Not really. Okay. I haven't included the performance metrics, but actually, for a regular service of ours, it takes like, without the incremental build, it takes 1.2 or 1.5 seconds on the regular laptop for the TypeScript compilation, TSC, and less than a second to generate schemas.
Okay, that's good.
Thank you. Any more question? There.
I have a follow-up question to the schema. Have you been using Zod, and do you know how it compares to that?
No, not really. Not
Okay.
really. Haven't
Because,
ever heard.
are you aware what Zod is?
No.
It's like you write your schema and you generate types based upon it. So I was wondering if you have any comparison about that.
Could you please repeat?
Huh?
Could you please repeat?
Zod. If I was wondering if you have any comparison, but you said that you don't have
You just
experience.
described how it works. You write what, sorry?
You write schema, right?
Alright.
And generate types based on the schema.
Oh, yeah, I think it corresponds to the question we already had.
Yeah, okay.
It's exactly the other way around, right?
Yeah.
One more?
I was thinking about that as well. So it's,
Yeah. Okay. So any more question? No, I don't see. Okay. So thank you very much, Amir. Big applause for him.
Thank you.
So let's take short 5 minutes break. I see also 5 or 6 free seats, so guys, you can have a seat over here. We will bring some more chairs and 5 minutes to plug in our second speaker. Okay, here we have three more seats, so you can take the seats here, if you want. Two more. Or even I see three more. All right, perfect. So let's start with our second speaker, Anna Ghukasyan. Ghukasyan, yeah, sorry. Yeah, she is a senior full-stack developer at Scopeworker. Her topic is Ngrx store, when, how, and why. So, big applause for Anna.
Okay, so how he said, we are going to speak today about the Ngrx store, and we will start about what is it, how to use it, and then when to use it, and why to use it. Yeah. Before that, 2 words about me. I'm Anna. I am working with JS 10 years, and I was lazy to take pictures, so I downloaded lots of logos. Okay, so Ngrx store is giving us more maintainable design, and it's making testing easier. A little bit of history before going ahead. So it was created, or initial release was in 2015, which was fixing this quite known already bug. That was when the number of unread messages was not showing correctly. So they were the Facebook team was fixing it in one place, and then this bug was coming again. And then they decided to just scratch it and create this new design pattern, which is called flags. And after that, lots of libraries were created based on this flags design pattern, based on the store architecture. What is Ngrx? Like, how does the application design look when we are using Ngrx? So Ngrx is like Angular and Redux. Redux is the initial library for store application, and so basically so our components are trying to change the main store through the action, which we will go one by one over all these components. So when we are calling some action, we can apply effects. And after calling some action, let's say login or logout action, the Ngrx library is going to make a change on the store using the reducer, which is a pure function. And a reducer is the only component here that is changing the store, the data that we have. After that, the component or other components are able to connect to that data through the selector. Here we have effects. These are the side effects that are being done when the action is called. They are usually a small piece of codes which are calling some service which we wrote or some basic logic in them. So first, what is store? Store is the in-memory database, we can say, in client side, and this is like single the truth is here. Every given time the store has the current state of the application, and in the code it will be implemented in this way. Let's assume our data is going to be used. The state, as we can see, this is the state is some custom type that we created. So we assume that we are going to need only this user data, but with it could be, let's say, if it's a shopping application, it could be cart where we want to save the current state of the cart and this type of information. So basically, this application is created. This state is the data that we want to save in the store. And in the code in Angular, we are going to create an instance of it, and later on use it like this. And about this dispatch, I will say later. Okay, so the next is action. Action is event which we are calling when we want to change something in the store. So it is very similar to just writing a new event and then calling next to it. But this is event which is created by the store, by the Ngrx library. So here we can see the create action function, which is from Ngrx library. And this function has only one required parameter, which is the first parameter, the string. It has this syntax. It has this syntax, which is not required, but it's preferable to keep because it's easier later on to debug. And the second one, the props, is also a function which is Ngrx giving us. And props is telling us what type of properties it's going to take, basically. And so here is the dispatch. With dispatch, we are dispatching this login action. So since login action we would call, let's say, after the user was logged in, we would pass user object, which most probably came from backend. And so as you can see, this login is the function that was returned by create action. And we are passing the same type of data that we defined there. Okay, so the next one is reducer. Our reducers are the ones that are actually changing, have access to change the data. They are pure functions. So pure functions are the functions that are that don't have side effects, and every time you call it, it's gonna produce the same result, which is very important in Ngrx architecture because thanks to that, the testing is much easier. Okay, so this is how it looks like, the reducer code. You are creating a reducer using the create reducer and passing the initial state of the application, and initial state in our case is nothing because the user is not logged in, and so when it will be logged in there, we will have the user. Okay, so selectors are for returning the data that we have. Selectors, it looks like observable. If you open the code of the Ngrx library, it actually is observable. So it's actually observable of some specific data that you want to use in your component. Yeah, so here we're again using the create selector function from the Ngrx, and in this case it's a user selector, so we are returning the user. So in case of, let's say, cart, because we were trying to create a shopping application, so in case of cart, you could say how many selector for items number, yeah, and then here you would return state items.length. So it will, every time the length will be changed, this observable will call next. Okay, what did I write here? So here we have our store. The store is the same instance from the store, and it's and this time it's select, and it is getting this type of object, the object which is returning create selector. Okay, the testing. Testing is quite easy. I brought only this example, but it's quite easy with Ngrx because we mainly use pure functions. The one thing to pay attention in Ngrx when testing Ngrx is that you should test actually your logic, not the Ngrx functions, because I see it a lot in the code that people are testing the reducer function, the selector function. So testing, we would say, how that reducer is working correctly, which is the job of Ngrx team. So we need to concentrate on the business logic that we wrote. Okay, so when to use store and why? Yeah, we mainly need store when wait a second. Yeah, we mainly need store in cases when the data is being modified in different places. So it is really hard to take care of the data's immutability. And it's becoming, like in a huge application, it's becoming really uncontrollable. Another case is that when the one data is being passed from one place to another place, and it is breaking the single responsibility principle, and it is making hard to keep components decoupled. This is fixing the bucket brigade issue, or the prop drilling problem, which is when you want to pass one data point to another, from one place to another place, you are passing it through the components in between. So if you have a hierarchy, let's assume you have a good hierarchy. So in that case, if you want to pass something from the parent to the child, you need to pass it through all the components. Or if you want to pass between components which are not in the hierarchy, they have, I don't know, different type of structures. So you go, I don't know, three steps up, 2 steps down to pass this data between components. Yeah, so in this case, if you are passing this data between the components, you have lots of components which have input which are getting input the data which they don't need. So it's also making hard for just look and understand what that component is doing, because it just gets and gets in, gets out the data, and it may make hard to understand what's the logic of the component, because it is getting some data which it doesn't need at all. So again, the single responsibility principle is being is not kept here. The Pete Hunt, who was one of the initial contributors for Ngrx store, is saying you will know when you need Flux. If you aren't sure if you don't need it. So it's pretty straightforward, yeah. If you know when you need it, but how do you know that you need it actually? Okay, so I tried to take the points where you actually will not need it. I mean, to pay attention to these points to understand when you would not need it. So mainly you don't need it when you have a small application where you don't have much logic and much business logic in the front end. And let's say if you have a create, read, update type of application, in that case, you might end up having more code written for Ngrx to keep the library working than the business logic. The other 2 points actually are almost the same. When Angular is providing you a way to do it without Ngrx, I mean, you can actually use still, but Angular giving us lots of opportunities, because unlike React, Angular is a framework, and you can do without Ngrx if you want. One way is Angular Router. Angular Router is almost like almost like a store. It when you look how it is working, it looks very much like a store application. And you can change the parameters in the router, and the parameters are also observable. So basically, it's like a selector when you are subscribing to the parameters of router. So it's very similar to the store. And yeah, the services and dependency injections, you can, since we have services which are singleton, so you don't need to care about the fact that you are repeating the code or it's injected in a couple of places. So you can create your setters, getters, or create observable, which is checking the data. Yeah. The issue with this last case is that, okay, you can basically do this. You can do everything which is Ngrx is offering with services. But then the hard part is to maintain the code, because when you start first writing this service, you know that you want to have a setter which is changing the data, and then you want to read it only through observable, you want it to be immutable, but then after that, like other developers can come and change your services. So it's always good when some library is forcing this structure to you. Otherwise, you will end up just writing Ngrx library if you want to exactly do force this syntax to the users. Yeah, and basically, if you are not using Ngrx, maybe just try to use. But yeah, so you can, what just said, you can use Angular services. You can use Angular services instead of Ngrx, and but you need to take care of about all of the maintenance. And it is really getting quite messy and hard maintainable when the application is growing bigger. In case of small application, it might be even simpler to not use Ngrx. And it's always good when some other library is taking care of what you need, yeah? Okay, thanks.
Thank you very much, Anna, for your presentation. Do you have any question to Anna? Okay, I don't see any questions. Okay, here, oh, sorry.
Sorry, is it something Angular specific, or it could be used with anywhere?
Store architecture libraries that are based on.
I mean Ngrx.
Ngrx is yes, it's Angular. Yes, the name is coming ng like Angular. Angular Redux, I think, Ngrx.
Any more question? There.
Sorry for the stupid question, but could you please name 3 reasons why do you still use Angular?
React? Or maybe you will
Just
start
3
introducing what is your tech stack.
Sorry?
What are you using for a technical stack?
That doesn't matter, that's the question.
Well,
to you.
I will answer more specifically.
Okay, if you don't want to answer, you don't need.
Okay, yeah, I can answer why I am using. Yeah, so Angular is a framework. Unlike React, I don't need to care much about architecture. So that is helpful. Of course, there are this type of frameworks like Vue.js. I really like Vue.js too. So Vue.js Vue is also like more Angular is more heavy than Vue. Yeah. So most probably I would I would have hard time choosing between them if I would start the project from the beginning. So you said 3 reasons, yeah. So that's it from me. Yeah. I had one reason.
I mean, you mentioned that the Angular is a framework, but you still integrate the Ngrx as the store here. So what is the benefit of?
So since Angular is a framework and since it was initially created by Google, it has lots of libraries, and which is making life much easier compared to when you are not using Angular. And obviously, when you are using some common solution, it's easier to find answers to your questions because it's just known and people use it. So that's another reason. As I said, Ngrx is created using Angular. So this is a library that is based on Angular. You can create the same by your own, but it's just good that somebody did it, yeah.
Okay, thank you.
Thank you. Do you have any more question? Here, okay.
Thank you for your presentation. You mentioned that the router could have been used as the store. How could it exactly be?
Yeah, router is also based on the store architecture. So it also you are changing it using the selectors that the router is giving, yeah, and you are actually subscribing to the observable that the router is giving. So I know that there is a store router, like something based on it, but I don't know how is it done. But the router, what I said is router is kind of store too.
Thank you. Any more question? Here, okay.
Yeah, a bit more in the abstract. The short question is going to be why exactly, and the long question is going to be like, we can use the service to achieve the same goal, right? Mm-hmm. The only difference is that for using the service to do the same thing, it's going to be much more complex when you're writing the individual parts for the service part, right? Whereas the abstraction layer for this, as I understand, as like thinking about, for example, the same in Vuex or React, is going to be a lot more work for the entire thing, but then it's going to be easier to do it individually, right? But since you shouldn't build a small app using Angular, because why? You can do the same in Vue.js, and it's going to be easier, and the architecture is basically the same. For big applications, you can use the service, and you can just think about it. Like, you do have the expectations, right? So you should know that you're going to use services to achieve the same goal. If you don't, then you probably didn't think it through, right? So what is the sweet spot of actually using this? Like, as another loaded question I'm actually genuinely asking, right? What's the situation in which you would actually need to use both Angular, have a good plan, and then use this?
Okay, so Ngrx is you can use it. You can create your services. Yeah. So let's say you have a service. So in my case, I had a shopping application. So so I would, in case of services, I would create 2 services. One would take care of shopping part. Like update the shopping cart number, update the items that are there, like, I don't know, maybe favorites, something. And I would have another service which would take care of the login and logout, for instance. Yeah. And in the end, I would end up having 2 different services, in 2 different services, taking care of this structure, which is creating like this setter that is updating it, yeah. And then I would also have this observable. So as a result, if I have many services which are kind of have the same structure, so this would be like abstracting this part, the boilerplate part, which you use to decouple the data from the whole logic, whole business logic, yeah. Decouple the updating data from the business logic. In that case, I would end up repeating all this structure for these services. So also...
That's the problem of the services.
Yeah, what did I say? Okay, yeah, and also another thing is that when you are creating your custom services, you also need to take care of, like when you look to the Ngrx code, you already know what is it because the syntax is understandable, yeah? So if I go to a new project and I use and I see Ngrx, I know what is it. But when I go to a new project and they created all their new services, which is doing kind of the same thing, yeah? And then I need to remember which store was which service was saving which data, and this type of stuff. Like, it's just making also easier to...
if you understand the store idea, it has a very rigid structure, right? So we understand the structure, so it's easier to read it. And yeah, that is true. The services are really harder to read than the store if you understand the store. But what would you do in this situation when you have some services set up in an Angular application to do basically the same thing, right? And then you need to implement Ngrx to do, like, I don't know, the updates, for example, for the counter updates that you showed, right? Do you then rip the entire service, or the services, right, and you lift it to Ngrx? Or do you use both for, I mean, for any reason, like having both services and Ngrx for other things?
Okay, so we can have, in Angular, we can have services for different purposes, yeah? So if you are speaking about the part of the service which is updating the data, then you would take it out and use the Ngrx solutions. But the services are also giving some services. They are implementing some custom logics, yeah? So you would still have these services. For instance, you would use them in the effects when you want to make some side effect when some action is called. Let's say when the shopping cart is added, yeah, you want something to calculate to call the API, for instance, and to update this shopping cart. In that case, you need these services. You still need services. This is not really, we are not replacing services with this. We are making it just the part of the services that is updating data we are taking it out, and Ngrx is taking care of it.
Yeah, I was then thinking more of a distinguishing line to have a reason for keeping the service and the store both at the same time, right? What is your reasoning for having both at the same time? Like, this is better for this type of operation, whereas that is better for that type of operation, right?
The thing is that you are saying what is the reason for keeping both, but Ngrx is not replacing services. You are deciding to use services plus Ngrx or only services, because you won't have a big application without services. So Ngrx is just doing some part of the services, which is updated, which is having some centralized data store and updating this data. So if you think that Ngrx is not needed, services can take care of it, then I guess you need to go ahead and use it. One of the contributors was saying, but it's easier to debug the Ngrx, easier because it's a common solution, so it's easier to debug because, if you have issues, you can Google it. And also the syntax of the syntax is making it easy to debug. For instance, logging mechanism, etc. One of the points that I actually missed is Redux tool, which is you can it's an extension Redux, and you can have it in your Chrome, and it will show all the time what is in the store, and you can react use it, yeah. During debugging, which is also helpful, yeah.
Okay, so basically, state management is use Ngrx when it's easy, and when you have to use the service, just use the service, right?
Yeah.
Fair enough. I will end my lengthy question right now.
Thank you very much. Any more questions? No, I don't see. Okay. Thank you very much, Anna, for your presentation. So now let's take 2 minutes break to set up our third and last speaker, and we'll be back in 2 minutes. Thank you. All right, guys, let's start our third speakers. Please take your seats, guys. Guys, please take your seats. All right, let's welcome Andrzej Frinch. He is a JavaScript and Clojure developer and Meet.js community enthusiast. So he will talk about atoms all the way down, introduction to Jotai. So let's welcome.
Yo. 3:13. Okay, the most important thing is that after my presentation, there's gonna be pizza. So stay around. And yeah, so this is important stuff. And my main goal for today's presentations is not to drop this beer on the floor because the table is wobbly. So if I manage to not drop beer on the floor, then I won. Also, you can ask any question in the meantime, but if anyone asks why React, I'm gonna leave. I'm not gonna ask any such questions. So yeah, these are rules. We can go on. So I'm gonna show you a little library, state management library for React that is called, I think it's called Jotai. I have no idea, honestly. Probably Jotai, maybe Jotai, maybe Jotei, whatever, but I'm gonna say Jotai. And po prostu. And I'll start with some old existing solutions to state management in React, and I'm gonna bash the old ones, and I'm gonna compare them with Jotai and tell you that Jotai is better. And I need to check. Yeah, cool, it works. So basically, we have Redux. I know there is other stuff, but like not everyone, is able to change their state management library monthly. So a lot of projects are still using React. I'm working in a huge project that is still using Redux, and I think a lot of companies, huge companies that use React, go with Redux because this is the way. And the problem with Redux is that it's shit. This is the main problem. Because, well, it shouldn't be like, I'm gonna explain. The first thing about Redux is that you have like, this is good idea to have action and to create action, then dispatch the action, change the state of your application, maybe call API, maybe do something, maybe then call another action. This is a really good idea, but like, honestly, having to use string as your identifier, it's poor design. Like I cannot tell it, I cannot, grasp this in any way different. Like we have functions, we know what a function is. We can navigate with our IDEs or our editors through our functions, through our modules and everything like that, and it's easy. And then we have, this layer, and I'd like to call it layer of indirection, layer of abstraction, but it's not. Like Redux actions, it's just a layer of code. It's not abstraction. So it's just a string. You'd have to fight me really hard to make me call string an abstraction. It's just code, piece of code, and then you can go on and create an action creator, which makes it nicer, but you still have the string somewhere hidden, and it's maybe you have the way to navigate your code better in more, I don't know, elegant way than I have. But when you have action creator, and for example, you want to go from action creator to your reducer, which is another point, and find what's gonna happen when you call this action creator, it's not straightforward because you're not calling this function, you're not calling the method, you're calling some action creator that will pass the string somewhere to the reducer, and then you have reducers, which are just huge switch cases, which are kind of mimicking classes with methods, but not really, because we have classes with methods, but reducers are not. Reducers are huge switch cases. And still, maybe you are on the next level, and you know how to write elegant reducers that do not get worse with time, but the reducers I saw are just huge switch cases. And it's really ugly to navigate, and I really don't like grepping my project, through looking for the particular action name. Even I know there are new ways, like for example, using a slash kind of namespacing your action names. It's it's something, but it's still just navigating through strings, and it's still using switch cases. I cannot imagine the world in which this is good design. This is just mimicking kinda OCaml something effects and trying to create classes that dispatch your action, but you're just passing strings. This is like this is bad. Sorry, maybe I should have more arguments. I don't. Like this is bad solution. So it's it's enough for me because I don't see any good parts of it. So what? Okay, yeah, I said. Redux, yeah.
Everyone that uses the store, they understand.
Yeah.
It's a shitload of work to just change the string.
Yeah, exactly. So.
Just a question.
Sure.
Have you tried Redux toolkit?
Yeah.
So what there are no strings.
Yeah, I know, but it's still it's almost the same thing. It's just. Yeah, but it's it's still not elastic, and the composition is still poor for me. So I honestly, I tried it, and then maybe I'm wrong, but my reaction was like, it's just more complicated Redux, and it's just complicated way to hide the strings, and composition is it's not on the level I would like to have. So yeah, I didn't really give it a proper try because I didn't see a reason. I didn't think it was good API. So the other thing I tried actually was MobX, which kinda is, it's kind of, you would say, it's kind of similar to in a way, to the Redux toolkit because you have class, you have properties, and you have proper actions as methods on your class. So this is, yeah, we're going like one step ahead. We don't use strings to identify our actions. We can just program like people. But, well, then, honestly, once again, I'm still bashing. Like the API to MobX is weird. First of all, there is too much options because you have make observable, you have make auto observable, you have action, running action, auto run, reaction, and all that stuff, which, yeah, it's elastic because you have different ways of doing the same thing, which is terrible idea. You shouldn't give people like 5 ways to do one thing in your library because they will, like, programmers will not be able to communicate properly. You go with one, like I'm with Python guys on this. Like there should be one way to do your thing, and then because MobX is more full-fledged than just Redux, they have effects, and it's like basically what I said. The API is weird. You need to remember about memory leaks because it's super easy to have memory leaks with your MobX effects. You have configuration for your effects, like delay, fire immediately, and whatnot. And it's just so then my reaction is, okay, it's like poor man's Ngrx.js. It's just like trying to be reactive, but not really. It's just like, you say you're reactive with MobX, but you dip your feet in reactive water and you claim you passed the whole ocean. Like it's, if you want to go reactive, like go properly reactive. So then, of course, I could say, yeah. Then we have Ngrx.js and just go Redux observable, because that's the solution. And honestly, I would like to finish my presentation here, because I love observables and reactive streams. They have like awesome operators just for anything you want to do asynchronously, for any actions you want to dispatch, you have proper operator. But then the problem with this, like nobody likes it. Honestly, it's too hard. It's simply too hard. I spoke with enough people to make my opinion that it's too hard to learn all this stuff, to learn on the concept, to learn, oh, this is a subscriber, there is a sync, there is a scheduler, and once you go into schedulers, you're done. Like seriously, at this point, you have like month done, and you still don't understand. So, if you work with people who, for example, created Ngrx.js, then go on. If you just work in normal project like most of us, this is too hard to really make people. And to be, fully honest, I once tried in one project. Maybe that's a really small sample, but it was enough for me trying to get people to work with me, like normal React developers, to work with me in FRP way. Yeah, it did not finish well. I left the job pretty quickly. So yeah, everybody was happy, especially the guys I worked with. Yeah, so to be fair, I'm just not happy with all these existing solutions that exists as for React state management. So there is this new funny thing that I introduced at the start. And as I said, reactive is hard. It's just too complicated. Even if you go to libraries like Most.js or Cycle.js, they are still complicated. You still need like 3 months of just going through the documentation, going through the sources, and understanding that you're not going to do it. I know. We are paid well, but still not that well. Yeah, I'm making jokes as it goes, so I'm happy it got some laughs. But we need reactive. Like seriously, we need reactive state management because we cannot just keep our state in our objects and leave it there. There has to be a way to communicate updates easily throughout the whole application. So Jotai comes in. Yeah, it has a weird name, but it's super simple. It has one concept. Because as I told you, convoluted APIs are bad. We need reactive, but it has to be super, super that simple so you can learn it in 2 days max, because at the 3rd day, you're going to lose it. I know. You're not going to spend any more time. Because you're going to, you'd like to have a beer, not spend time learning libraries. So this is the API. And basically, if you know this API, you're almost done. I'm just gonna try you, and this is like a little harder, because you can have atom with a value, or you can have an atom with writer and reader. So you can describe the way to update this atom, and you can describe the way to read from the atom. And actually, yeah, I think my writer and reader they have wrong order. Sorry, yeah. This actually, yeah, my bad. So first one is reader, the other one is writer, but I'm going to show it in the code, so it's not that bad. And then once you created this atom, you go and you use it like you would use your use state in React application, which is actually one more point for me, because it's just that simple API, because it looks like use state. If you know React, you know hooks. Like I think right now you know hooks. You ought to. So if you know React, you can replace your use state with JOTI like that, and it works, because the basic API for read and write is the same. It's basically all the same stuff. And then you have a little more. And then I'm just going to show you a really, really little code to introduce you to this more complicated part. And I'm going to have some fun with dragging these windows. Yeah. This one is good. Am I good? I hope. Cool. I can. I need to go here. And then I need also to give you the code, and I'll be good. Yep. Almost there. Good Lord. Give me, please. Yeah. Yeah. Awesome. Jesus. I won with computer. Okay, so just super simple read and write function. So there is this little application that I wrote in JOTI by myself. So if you ask me if I wrote anything real, yeah, I did. Nobody paid me for that, but I actually used JOTI, so I know a little bit. So I have this little application for bike rentals, and I have this option that if you want, you can filter by availability. If you don't want, just leave it. You can just go through bikes with super weird names like Bryce, Senna, whatever. I don't know the producer of this bike, but it's in the application, so it has to be true. So if I have this filter by availability. I can have it turned on and off, and then there is a little condition in here. It would be good that to have it like end date has to be always at least day after start date. Yeah, I think it's a good condition. So I did this little trick in here that, for example, yeah, the start is 27th, but for example, end is 28th. I want to rent a bike since 30. And then, as you see, it changes to 31st, which is cool. It should work like that. And it works like that because I just created this atom, which is start date filter atom, which gives me first read function and then write function. So in read function, as I showed you, yeah, if I can turn it off and it's not being used, I can turn it on and then it's used. So there is this just little condition in here. If filter is on, use the real value from the atom. If filter is off, just say undefined, because certainly we don't want to use the filter. And then we have a writer, and the writer is just a simple function that says, okay, if current end date is after the payload is before the payload you're giving me, then set this date to be, day after. And that's basically it. There is my whole facade for creating this complicated condition. And this is how I read and write. And just, to give you a little glimpse into this, I'm just going to show you also that's going to be all of the code. So, I'm almost done with my code. I'm going to show you a write function, and yeah, just a second in here. Okay. Ah, Jesus, where is my mouse? If I don't find it, I'm gonna, yeah, okay, so right function in here, and up. And yeah, so this is read, write, and this is, I'm gonna show another little nice thing with writing into atoms. Because, I showed you we have these atoms, we have ability to create a value, then we have ability to pass the value somewhere to use it, but it was really small value because I had only a filter and one checkbox, which is not a lot. This is like in most of your applications, you're gonna have bigger state trees. So this is one of my bigger state trees, which is a list of bikes. And what is really nice about this library, about Jotai, that it actually gives you a way to really easily dig into the big data structures. So I have two optics in here, and I'm gonna show you the code in a while, because I have a list, and I need one optic, one level of access to my data structure, which is I need to access the list as a whole. So for example, I am able to click delete and just delete a particular element from the list. And it's cool, I can do it easily, but then I also need to, for example, change the particular elements of the list. And I want to be sure that if I change the element of the list, the whole list gets updated, all the stuff. So the read and writes are nice like that, because I have access to something called optics, which allows me to use on one level, as I showed you, on one level I have this bikes atom, which is just all of my bikes. And I have more complicated code here for the reader, because there are some filters applied and stuff like that. But also I need, and as I've shown you, I'm just gonna call delete. So if I call delete, which is here, I'm just gonna access this bikes source. Yeah, not that. Jesus Christ. Yeah, don't use Emacs in your presentation. Never. Seriously, this is quite terrible what just happened. Never use Emacs in your presentation. Yeah, can I do? No. Yeah, I'm done now. This is basically just a second. Yeah, maybe. Done this. Yeah, it's really easier if you do it at home. Nah, it's Emacs. Sorry. Okay. I'm just. You have Okay, let's get back to the presentation. So as I've shown you, have this list, and I have this delete bike atom that operates on a level of my whole. Jesus, yeah, but I need to access this thing. So, can I access, or are you just leaving me? Yeah, okay, not escape. It's a bit more. Can I do space? Jesus, what I did? Okay, I'm gonna close this. Yeah, I know. I know, this is fucking true. But yeah, I've shown you what I wanted, so I'm just gonna go on and act like nothing happened. So there was this one optic on the big level on deleting particular element, and then I have this other optic, which is here. So I'm doing a focus atom, which is just still atom. So like this is, another new part of API, but I'm still just using the same atoms. This is not any kind of new concept. It's still just Jotai focus atom, and I'm gonna tell that this atom is, a part of my array, and then when I have it, I'm just gonna call in my, particular component, which is just one bike. I'm gonna use set bike with access to only the part of this array. So I can have, optics that I can have a huge structure, but still I can have small atom that gives me access to small part, which makes it super fun because I'm still using the same API all the way down. It's still just atoms, still just read from atom, write to atom, be done. That's basically it. And that was all the code I wanted to show you. So I'm good. I'm not gonna show more Emacs. And yeah, so this is what I So yeah, what I told you, you can easily access big data structures via optics. And it's just like this is still the same API, which is honestly for me, it's way nicer than just pushing this huge data structure and trying to remember what part actually you are actually accessing, because with this optic, in every single component, you access only the part of the data you actually care about, and you have the same API you would use in any other place with this library. Yeah, that was the presentation part. Jesus, it was not that good. I'll remember to use VS Code on presentations. Emacs is too tricky. And then, yeah, to close up fairly quickly. Yeah, the API is easy. Integration with React is just done properly because, as I told you, you can just replace your use state. You can replace your use reducer with Jotai, and it will work. You can, if you really want, use reducers. They also support that. They also support React suspense. So if you have any async atoms with state loading, anything like that, you just use suspense and you're done. This is another plus because it's properly integrated with the library that it's built for. Then you have integration with React Query. So if you use React Query because you don't want to handle any fetch calls and all the state of API, whatever, just go with React Query. Then if you want to go from Redux to Jotai, just use their integration with Redux and be done with it because they are nice like that. And they allow you to push all your stores to Jotai and gradually migrate if you care. And then also the another integration is React DevTools. So if you use Jotai and you want to debug your code, just go with React DevTools. Because as I said before, guys who created Jotai are nice like that, and they just integrate with all the existing tools you could imagine, and you can just go on and use it today. A beer, yeah. And I still didn't spill the beer on the floor, which is good. So, in a few words, what I was talking about. You have Atom. This is a box for your data. It's fairly easy to understand. Piece of data. You can write to Atom. You can read from Atom. Also fairly easy. You can compose atoms easily, which is, if you want a value from atom to be dependent on the value from the other atom, just call, get this atom and create new value, and you're done. Really nice thing, atoms are GC'd. So this is, I cannot say what's better, because in Redux, if you have huge state trees, you need to clean them by yourselves. If you have a bunch of data in there and you're keeping it there, it's gonna stay in there. You may like it, you may not. I think for most, in most occasions, you'd actually like this to be garbage collected. So atoms are garbage collected. No memory leaks, no shit like that. You just write it, you leave it, and you're done. And you can build bottom up, which means that you can just start with a bunch of atoms at your local level in your components, and then you can compose them easily and take them out to models, and it just works. So the difference from other libraries, from most of the libraries, state management libraries, where you have to start with your huge model and then you pass data down to your components. For me, the development is not that nice if you have to start, because it's like nobody knows the proper, I know you spoke about the structure, nobody knows the structures when the project starts, seriously. I certainly don't. So this is a nice thing about Jotai, that you can just start locally, you can start with your state in your component, and then there is zero cost to taking this state out and composing with other parts, which is also really nice. And that's basically it. So thank you so much. Yeah.
Thank you very much. Do you have any question? There.
Yeah, it was a good presentation. Just wanted to know, is it compatible with the older version of React? Because I could
yeah, I think it's. I think it starts at 16.
Hooks, basically.
Yeah, it works with React 16. You can use suspense. And, you need hooks support.
So,
If you have hooks support, then you can use it.
so that means internally it might be using use context or those.
Yeah, it might be.
So why can't I directly use context and do the same job?
Well, if you like, I'm sorry, and I'm gonna steal your answer. Like, if you want to write your own thing, surely. But if you want to have a library that's ready to use to be tested, they have means of testing that is already. They have integrations with all the debugging stuff. They have integrations with other libraries. Like, it's done, and it's super small. Really, it's, I don't know, 100, 200 lines of code. So yeah, my only answer is if you really want to write custom solution, go for it. But if you want to have solution that is already prepared and it's properly reactive, like it allows you to write code that is easily updated and easily read from, and it's ready. So and it's super small. So I don't see a reason to write own solution.
So basically, Atom is internally using use state and use context?
I use state for sure, and probably use context too. Yeah. Sorry? Can you get a microphone?
I think it doesn't use context. It's just some state that is separated. Like it has its own states.
Okay. Yeah, I know.
It's like you can create context on top of it, but it's not mandatory.
Honestly, I don't remember if there is use context in codebase. I don't remember that, so I'm not gonna say.
When was use context? Because hooks in general were 16.8, right? But use context is a newer hook. So the question is there a discrepancy between one and the other? Or?
No, there's no context. Like basically, it's just some internal stuff. You can add context on the way to come to separate it. But there's not use context.
So I mean, there's no provider, and there's like updates based on the value.
But I'm like, now I remember that if you want to test Jotai, there is a component that allows you to inject some values from the end closing component. So probably they need to use context for that. I would think so. Or something similar.
Fair enough, but I do have a super question.
Yeah.
Just because the fact that the keywords were getting set. So I assume that it's the processing of get and set is just the keyword that they decided to use, and it's still on the front end, right?
Yeah. It's just
like the first processing of the data on the front is on the front end, and then it goes to the back end if you choose so, right?
Yeah, sure. Like
Okay.
if it's a front end library, I actually did not speak a lot about backend in here, so yeah.
Okay, so what's the difference in structure between, because we have the actions reducers, combine reduces the store, right? So this syntax is definitely shorter. You have a lot less steps, right?
Yeah. And
so how would you high level define the structure that you need to understand, like all the different points until you get to changing the state?
Yeah. So if you'd like to, for example, migrate from Redux. In Redux, you have a structure. You have, let's say, we have action creators, and then you have, switch case. So in Jotai, you would translate all your, basically everything to Atom, which means like you're gonna have a source Atom with your data. Then you can just write to this Atom directly. But if you want to go more fine grain, and for example, you need particular actions, then you just create a new writing Atom, and you say, oh, you use this Atom and write via this Atom like a facade. So one action might be one Atom if you need, more.
Okay, but the Atom is like the store, basically for one value, right? And it's also the thing that you call to change the value. It's not like a central data manager like the store is.
Yeah, there is like you don't have to use central data manager in here.
You have a lot of atoms, right?
Yeah, but still, as I shown, because you can build either way. You can start with a lot of small atoms and compose them, but you can also start with huge atom and build optics. So like if you, I had a list, yeah? I had this huge list of bikes.
So it's like with a database, you can both store it, scale it horizontally, vertically. You can just flexibly choose whether you have a big fucking atom with a lot of data, or you can have like one atom, one piece of data, and you have a lot of atoms, right?
Yeah, because the atom is an entity in which you store data, but it doesn't have to be this, like atom is not the same as your data. It's an interface to communicate with your data. So you can have one huge atom and then build these smaller atoms that are ways to access it. So
you can build like a selectors.
Yeah, you can say, but so you can read write selectors to your data structure. Because sometimes it's easier because sometimes you actually have a big data. For example, the list. I'm not gonna start with, if I have a list, I want to keep a list. If I have for example, a person and this person has a job and some bank account and something, I want one data structure for this person, but also the ability to access particular parts.
So you can decouple the accessing. So
yeah.
like certain modules might want certain type of data, and the other modules want another type of data, and you just can separate the API for that.
Yeah, exactly.
HMs. Okay.
And you still keep the same way of accessing it because this is atom with write read, so the API is all the same whenever you access a huge data structure or a smaller part of it.
Okay, and I have another question about the optics. You've talked about optics. What are the optics? Because you've used that word Herald. Are they like selectors or what?
Yeah, it's called differently. It's called optics, it's called lenses, it's called selectors. If you want to be properly functional, you mostly use name lenses. If you want to be TypeScript functional, you use name optics. If you want to be React understandable, you use name selectors.
Okay, thanks.
Thank you.
Actually, you talked a lot of good things about Jotai.
Yeah.
What about the limitation?
Limitation?
Yeah, what did you face?
Well, of course, at some point there are some edge cases. So, for example, but I actually found out that most of the edge cases are taken care of. So, for example, I had a problem for a second when I was building the applications that I wanted to have an atom that has a default value that can be changed later, but also have a way to get back to this default value. And first I was like, shit, it sounds hard, and I probably need 3 or 4 atoms for that. But then I digged a little further, and I saw that the guys built that already. So they found out about this edge case. Other problems, well, I would say, let's say comparing with Redux, it's probably easier to get messy with Jotai because it's more elastic. You can just, for example, it's easier with Jotai to put some of your state locally and forget about it. With Redux, it's harder because you have one store, you have other store. So I would say more rough edges from the easier development because it's more elastic, but easier to actually shoot yourself in the foot and forget about something.
Okay, great. Actually, because this triggered my question right now. What you said, that's a very interesting description. Then do you know or do you think some kind of patterns are emerging, or are there some patterns like good practices, suggestions how to work with it so that I don't shoot myself in the foot?
Yeah, because as you've heard, I'm also a Clojure developer. I'm sorry. I was also working in a Clojure language, and this concept is actually well known in Clojure and in the library called Reframe. So the first reason why I actually got interested in this is because I know the concept from other libraries in Clojure. So if you go to Clojure Reframe, they have a little more complicated API, but the idea is almost the same. So because Jotai is not that well developed, meaning not enough people use it, I don't think they have good practices properly established, I know it's kind of shitty answer because it's Clojure, but I would go to Clojure myself and learn reframe, and then get back and create the same structure. I know what I know it's the answer. Like, yeah, but this is my real answer.
I have a question. Is it available in other, let's say, in Vue or in Angular? That's one.
I don't think so. I don't think so. But, well, it would. I think it's built React first. I don't think if I'm. Yeah, because the guys who build it mostly build React libraries. So you'd probably need to push them really hard to make them port to other frameworks. But yeah, this is React first. And
Is it open source?
Yeah, it is open source and it's super small. You can read it in 2 hours.
Okay, we have a question there. There was first, sorry.
Sorry, just a tricky question. So you've mentioned that idea from Clojure and reframe, and there was some wrapper, I believe it was Reagent, for React. So the question, what would you prefer? Injection those ideas of item inside the React, or rewrite the application on Reagent and use native items and injected React stuff?
So the question is,
would you prefer using Clojure instead, Clojure.js?
Yeah. Any day of my life, I would prefer using Clojure if they paid the same. Then surely, I actually worked in fairly, let's say, it was fairly huge project that was reagent based. Yeah, Clojure, sorry, I should have more arguments. I have some. Clojure is way nicer to work with. It's way more elegant. You have just language is better designed than JavaScript. So I would stay, but it's not as good to make me stay regardless of the salary. Yeah, that's the answer.
Okay, here was the answer to question 2.
So I have a question about situation when I have a couple of states, so like state machine thing.
Yeah.
The easiest one is like is loading data error. How do I do that without like introducing a switch case into my setter again?
Yeah, so there are 2 ways. If, for example, if you actually want to handle, because you said like you have error, like success error or something. So if you have a situation in which you load some data, if this is the state of API call, then you just probably the best way is to go with React query. But if you need to build custom state machine, there is one integration that I missed in here because I thought nobody would care, but there is integration Jotai X state. So if you actually want to go with state machines, you use X state to build your state machine and inject into Jotai because they have integration for that.
Okay, but then why would I use Jotai if I already using X state? Like they have a lot of those features, and X state is like heavy thing for like
so
small states.
You answered your question. If you think you should use X state for whole state of your application, then God bless you. You can do it.
Yeah. Good luck. So my question is like state, like state machine without X state and all of the.
Without it.
Yeah.
Okay. Jesus.
So like small state machines. Like I don't need to shoot a fly with a cannon.
Yeah. So it's probably. Then you probably forget about all that I said, and you go with reducer.
Okay.
Yeah,
that's fair. Thanks.
Any questions? There.
I would be interested to know if you would like now that you know that and you can compare it with Redux.
Yeah.
Would you use it like in terms of which kind of application, small, large, medium, and why?
I would use it over Redux in all applications. I would honestly, right now, if we speak about real-life situations, I don't make tech stack decisions based on tech. I would make tech stack decisions based on people, because I would not force. I tried forcing people to use my stuff, and I am not skilled enough in people communication to make it work, because I get angry. So, from technical point of view, personally, I would use Jotai every time, because for me it's way more flexible, and the code navigation by itself, it's just way better than Redux. From real life point of view, they pay me to work in Redux, so I do it. When I have my own startup.
Thank you. Any more questions?
Cool.
Okay,
so
I don't see.
Oh, there is one.
Okay.
I'm sorry for that.
For a second, I thought that you have a question to yourself.
Well, we can get to the back later. But I'm asking about the API because there are get and set functions that are exposed by the callback. Why just not expose the state and just work on state? I know it's you can mutate it and you can work in an Emir library.
Mm-hmm.
So do you know why it was built this way in case of Jotai?
I would say the first thing that comes to my mind is that they wanted to make it look like React state. So you basically, if you start, if you migrate from use state or use reducer, you basically have the same thing. You have state that is, if you have use state, you do not expose state from your use state hook. You just have it hidden in the hook. So I would say they probably wanted to mimic the React API, so you can just start right on.
So you mean to stay reactive, they have those accessor functions?
Yeah.
Okay.
Yeah, so it works the same, and you cannot access the state from outside. I would say this is to mimic. I think, I'm not sure, but I would say probably to mimic React API.
Okay, thank you.
Yeah, and now I have a question to myself. No, sorry. Because besides making the presentation, I'm also, right now I'm organizing this meetup, so I wanted to thank Andersen guys for hosting us and giving us beer, and I've heard pizza is coming. So thank you so much. I don't want to take more of your time. I'll see you on our next meetups. Write me if you want to make presentation, if you want to sponsor us, if you want to do anything. Huge applause for Andersen, guys. And thanks for all the speakers. Thank you for coming, and I'm done. Thank you.
Thank you very much. So thank all of guys to participate our meetup. I really enjoyed all presentation. Do you? Yeah. I don't hear.
Yes.
Great. So you will see QR code to our social media. So go take your phones, scan the QR code, and follow Andersen in social media. Right now, I would like to invite again all our speakers to the stage. So, come on. Come on, guys. We have some small gift for you as a thank you for your time and a great presentation.
Dziękuję bardzo.
And now, time is come. So let's go eat some pizza, chat, chilling, and have some fun. Thank you very much, and see you soon.